I want to talk to you about a U.S. patent that I received several years ago in the field of electromagnetism and specifically a magnetically coupled rotor system. Magnets are a form of stored energy like batteries, and like everyone, you become at a young age kind of fascinated about how magnets work. They have a north and a south pole, and these are indications of two south poles. And when you put like poles together, they don't want to, they want to push each other apart. And you can feel like kind of a bubble, which is the magnetic field as it moves through the shape of the magnet. If I turn it the other way, north-south orientation, they attract, and so they repel with like, and they attract with north and south. So you can actually push things around with this field. As you push one, it pushes the other, and it has sort of a rubbery effect. So I began to think about this when I got a hold of a bunch of magnets, and I started to think about how a motor system works. And this is basically out of an electric drill, and it's the rotating armature that goes around an arc segment magnet like this. And this electricity makes this rotor spin. So this is a armature that is a rotor. In brushless systems, the magnets can actually spin around the armature as you change the polarities in these electromagnetic system, so you can push the magnets around instead of the armature. So I came up with this idea that, well, in a brushless system, if you can move the magnets around, there's no such thing as a singularly poled magnet. So the magnets that are spinning both, have a field that is driven by the concave structure. The outer part of the magnet is just basically the housing, and it just spins. So what I thought of is, well, why not couple that exterior magnetic field outside of the curve of the motor magnet? So I started to think about, how to do this, and eventually I went to a company called Stanford Magnetics, and they make neodymium magnets. And I said, well, can you make a specific shape of magnet for me? And so I ended up making a shape of magnet that's like a convex lens. It has an arc segment on the inside, and it's flat on the outside. Now, one of the reasons I did this was through empirical understanding of what I was about to try and do, which was couple the rotation of a magnet to other magnets and have kinetic energy transferred in a sort of a virtual gear. So it takes 6 of these arc segment magnets to create the circle that would go around an armature in the middle. And I had these magnets made so that they're what's called axial polarized. The magnetic field is coming through the magnets in this direction. And so as you go around an array that I made, you go from south to north to south to north, just like you would in a standard electric motor. So with, machining and some really precise machining, I had the magnets made, and I had these rotors made in the form of a set of rotors which have a bearing at the bottom, which you can't see, and a shaft. And these are the magnets, and the inside is curved. So what happens in the north-south and north-south orientation, if I spin one, I have them all spin. Now, why and how could this be useful? Well, there are several things that this patent covers and some that have not been patented, and I'll discuss some of those things right now on this video. So if you think about how wind turbines and hydroelectric plants generate power, you have, in the case of wind, you have a blade. In this case, for power generation, they're sometimes 300 feet long. They're up in the air. The whole generator is up in the air. They take a lot of, labor to service and expense to service those huge blades. So I thought, in a magnetically coupled system, perhaps you could get less startup inertial resistance. It requires a certain amount of wind for that huge turbine blade to spin. The same with a hydroelectric plant. You have these huge turbines. So I thought, well, in the original internal combustion engines, they consisted of one cylinder, and they just made the cylinder big enough and bigger to create more and more power. Eventually, someone invented a coupled system where the crankshaft would be connected to multiple cylinders. So now we have like 8, 16, 4-cylinder motors in internal combustion. So when you couple all these motors together in internal combustion, the pistons driving the crankshaft, you have friction at the crankshaft. So what I thought of was, well, in a magnetically coupled system, you could potentially eliminate that source of friction by having what's kind of a virtual gear. So you can influence kinetic energy and transfer it without a belt or like a chain, which creates friction. So this type of magnetic field can be oriented in any direction and it will still spin. This will also operate at sub-zero environments in outer space because, without the expansion and contraction possibilities of a band or a chain. So imagine, if you would, this center rotor connected to a turbine blade. And when it spins multiple things, multiple parts of the array. You can take your armatures and place them inside of these arrays. And as the magnets spin around the fixed armature, since the magnets are creating a field through a wire, this creates a current. So you can capture this current. The other thing that's unique about this is that it can be oriented in different ways. You can line them up as a linear system when they spin. And this has more of a gear field because of the way the magnets line up, the arrays line up together. What's also interesting about having this type of magnetically coupled system is that you can influence things through a non-conductor. So if I had a non-conductive tube running around one of these arrays and put a blade propeller in here, then I could spin that closed system without having a shaft going through and propel either liquids or gas. So this could be used as a compressor or a pump design. Now, they already have magnetically coupled pumps because they don't have the problem of getting clogged up or and breaking the gears because it just slips. It's like a slip system. So what is interesting about this is that this type of setup where you have an arc segment like this, the magnets are like a physical structure. The field you can't see, but at these corners where these two arc segments meet is a gap angle. And this is kind of the differentiator of my design, my patent. These are only one-of-a-kind magnets. They've only been made once. I made them, I designed them, I had them manufactured. What occurs is since the polarity, they're axial polarized and the field is going through the magnets this way and this way. At this juncture right here, there's like a node of magnetism that's increased of strength because of the thickness and the physicality of this, the magnet itself, creating a more dense field at these corners. So this allows for a stronger coupling than conventional coupling systems. And this is scalable, so these can be either size. These magnets are actually bigger than the ones in this arrays right here. But when you sort of show, like through iron filings, how this field looks, it's, as you can see, at the nodes, this is where the corners are, there are these projecting lines. This is where the coupling is occurring. And so you can see as a kind of a natural phenomena, as you put more and more magnetic arrays together, you have these invisible fields that are projected. And as any one of these moves, it moves them all. So in a closed system like a pump, you can have a motor driving the magnets and the magnet spinning a turbine and gate valves. And so you can have a pumping system or a compressing system that has a closed system. So there's no shaft going into the tube where you want to compress or move liquids or gas. In a windmill, and I'm just going to show you just one design. You could have the windmill spinning at the top, a shaft, and it connected to a whole bunch of rays. This has the advantage of you being able to service your wind turbine on the ground if one of the wirings burned out or electrical lightning strike hit it and did some damage. You could repair this pretty easily. And so there are multiple ways that my patent could potentially be of use. So I hope that someone out there in the internet world can sort of see and understand what I've been getting at and potentially help with, moving this potential for green energy in the field of wind and water turbines even with tidal currents where this the friction is eliminated. It's so easy to turn this with no, yes, there are bearings here that will create friction, but not having a belt or a gear drive a kinetic system could be very useful for transportation, pumps, compressors, electrical power generation. Thanks.